Welcome back. So, as mentioned, when the Earth ruptures and moves, fault, it creates an earthquake. What is felt are the seismic waves rippling through the Earth. Once it gets to a location, that's what causes the shaking. So, let's take a look at some of these, shall we? So, when an earthquake occurs, a number of different types of seismic waves are given out. All of these occur at the same time. Some are faster, some are slower. So it really helps to figure out a number of different things. How big the earthquake is, where it's located, etc. So when an earthquake occurs, there are things called P waves that are emanated, primary waves, S waves, secondary waves, and then surface waves. Our focus is going to be mainly around P and S waves, known as body waves. These are waves that travel through the body of the Earth. Having a little bit of understanding of these two types of waves will help you figure out certain things that we'll do in class. So again, body waves. They travel through the Earth's interior. P waves, primary waves, are known as compressional waves. They're compressions. Yeah, imagine kind of compressing the Earth, and then that compresses the next bit of Earth, and that compresses the next bit of Earth, and so on and so forth. So they travel faster than S waves, and they can travel through solids, liquids, gases. It's how you hear voices. It's how you hear sound. It's a compressional wave. There's some physics involved there. Because of the sheer physics of a compressional wave, it just makes it faster. And you have S waves, which are shear waves, kind of back and forth. These are slower as they radiate through the Earth, just by the sheer physics of the Earth itself. They only travel through solids, but they do cause more destruction in regards to an earthquake. So if an earthquake occurs and you're 100 miles away, the first thing you would feel would be the P wave. It travels faster, gets to you first. Second thing you would feel would be the S wave. It's slower, so it gets to you second, but it's going to do a lot more shaking. Surface waves, just for your reference, they travel on the surface of the Earth. These are things like Rayleigh waves and Love waves. They are a little complicated and not necessary to understand earthquakes at the level at which we will. So what I will do, though, is kind of show you how P waves and S waves, what they kind of look like, how they kind of travel through the Earth. So let me pause. When I come back, I'm going to set up a little demo with a slinky, and we'll see where that takes us. 1 second. All right. Thank you for your patience. So here's a slinky, and what I'm going to do on my dirty floor of my office here is illustrate what a P wave and an S wave looks like. All right. So a P wave is a primary wave or a compressional wave. So for this, I'm going to compress. I'm going to push in, and what you'll see is kind of this little wave travel down and back. And that's known as a compressional wave, and that's what P waves look like. So here we go. All right, you kind of see it go back and forth. That's a compressional wave. They travel faster through the Earth. That's what a P wave is, a primary wave. Since they travel faster, they get to a location first. It's the first thing we detect, P waves. S waves, while they are emanated from the focus of the earthquake at the same time as a P wave, they just travel slower. So they get to a location second. They just travel slower. That's like, a Ferrari and a Prius are at a stoplight. It turns green. They start at the same point, but the Ferrari's going to get to the next point quicker because it's faster. But they start at the same time. So an S wave, it's slower, but it is more destructive. And you'll probably see why. So an S wave is a shear wave. So it creates kind of a back and forth motion. So maybe you can figure out why the S waves are more destructive. All right. So that is going to be your shear wave, your S wave. So you can see with all of that movement, that's what's going to make S waves so much more destructive. They're slower, but once they get there, we can see it on readings of earthquakes. When the S wave occurs, a lot more shaking going on as opposed to the primary compressional P wave. All right. All right, so you know the difference between a P wave and S wave. Again, we'll focus on body waves in this class. In lab, even in the assignment, you might hear, mostly talk about P waves, S waves, body waves. Not too much in surface waves, not necessary for the understanding that we will need in this class. Before we go, let me go ahead and give you another part of the super secret code. It is the number 6. Okay. Again, another part of the super secret code is the number 6. One more time, the number 6. All right. So that brings us to the end of this section, a little kind of a short one. When we come back, we'll talk about measuring earthquakes. We can use that P wave and S wave information. We can use other things as well. There's a few different ways to measure earthquakes. We'll talk about that when we come back. See you in a minute.